So we're going to start off by looking at 9.4 part 2, which is on ellipses. Okay, we've looked at parabolas, which was our first conic section. Now we're going to look at ellipses, and then the last one we're going to look at is hyperbolas. Now, one thing with ellipses is they're really similar to circles. So if you understand how to do an ellipse, then you'll automatically understand a circle, because a circle is just an ellipse that has the same width and length, basically. All right, so we always start out by looking at the definition, how we describe it, and then I'll show you guys a picture that usually, I think, makes a little bit more sense. So first of all, it's a collection of points in the plane, meaning it's a two-dimensional shape. Such that the sum of two distances is always the same. So when we looked at a parabola, it was a collection of points that were equidistant from two things, a focus and a directrix. This is a collection of points that if you add up two different distances, it always comes out the same. And let's take a look at that. All right, so here's a picture of an ellipse. B and C are two special points in the ellipse. And I'll talk about what those are in a second. But what I'm going to do is I'm going to take point E, I'm going to drag it around to different points in the circle, and I want you to watch what happens as you add up the distance from B to E and the distance from C to E. I'm going to add those two distances together. The sum of those distances is 17.3. Right? And here's each individual distance. Let's take point E, and as we move it, the distance from E to B and E to C changes. But the sum of the distances always stays at 17.3. That's what an ellipse is. And if you were going to draw an ellipse, this is basically a pretty good sketch that shows you how you do it. If we had like a bulletin board, and you take and put two push pins in it, you have points B and C, and then you take a loop of, basically you take like a loop of string, you put it around those two push pins, and then as it stays in those push pins, you pull the string tight and you drag your pencil around, keeping the loop of string tight to the two push pins. It's kind of like a circle where if you just have a single push pin, you just keep it pulled tight, and you bring your string all the way around, you get a circle. Well, if you do it with two push pins and keep it tight, you get an ellipse. And as you make the two push pins further apart, it becomes more elliptical. And if the two push pins come to the center and became the same point, then you'd have a circle. Right? But that's basically what an ellipse is. We're going to look at two cases of the ellipse. One of them will be when the ellipse is horizontal. The other one is when it's vertical. Right. So any questions on that definition? So those two special points that are inside the ellipse, those are called the foci. And that's one of the things that when I ask you to discuss the ellipse, you need to write down the foci. And there's always two of them. So what this is saying in red, this equation over here, is saying that if you add up the distance from any point to the first focus, and that point to the second focus, it always comes out the same. In the problem I made up, it came out to 17.3. So F1 and F2 are the two foci. And then if you draw a line through the foci, that's called the major axis. And that would be something I'd ask you to describe when you talk about an ellipse. I might say, like, which way does the major axis go? Horizontal or vertical? The major axis is always through the foci, And it always goes through the ellipse the long way. If you find the midpoint of the segment that connects the two foci, that's called the center. So here's the segment that connects the foci. Find the midpoint of that segment, and that's the center. If you draw a line through the center, perpendicular to the major axis, you get the minor axis. The minor axis always goes through the ellipse the short way. So going up and down, in this case, that's the minor axis. And then there's two more points. I labeled them in the diagram, V1 and V2. Anyone have a guess what those are, since I used the letter V to name them? Yeah, and there's two of them, so those are your vertices. Your vertices are where the major axis intersects the ellipse. So the 2 points of intersection between the ellipse and the major axis, those are the vertices. And I think that covers most of the vocabulary for ellipses. A couple new terms: major and minor axis. Center. Well, I guess that's a new term because parabolas didn't really have a center. We had a focus and a vertex in a parabola, but only one of them. Now we have two. And one thing you want to remember about an ellipse is that the foci are inside. When we talk about hyperbolas, they're going to have foci and vertices as well. That'll be tomorrow. But the foci are going to be outside the vertices. With an ellipse, the foci are inside the vertices. Any questions on any of those terms? And the kind of questions you're going to see is pretty much identical to parabolas. I might give you information and have you tell me an equation, or I'll give you the equation and you tell me the information, or from a sketch, tell me the equation. So same kinds of questions. So there is only two cases for an ellipse. There's the case where it's horizontal and the case where it's vertical. This is going to be the case where the ellipse would be horizontal. As always, we're going to start out with the center of the ellipse at the origin. That just makes it a little simpler. If we want to shift it, we can do an HK. If you remember, like we did with the parabola, the x minus h, y minus k thing. For parabola, we can do that here too. But let's just start with it at the origin. And let's kind of look at some of these things and see if we can make sense of the equation. First of all, big difference from a parabola, both variables are squared. In a parabola, only one of them is squared. Another thing that's different is we put everything on one side, and we always get it equal to 1. Always. That's like in a parabola, you always have 4 after the equal sign. Well, we're always going to get it equal to 1. Another thing that will always happen with an ellipse is the A value is always bigger than the B value. And they're both greater than 0. So A and B can never be negative numbers, or 0.
A always has to be greater than B.
A has to be greater than B, yes. And let me show you, I want just kind of look carefully at this. See how A is under the X and B is under the Y? Let's go here for a second. Now, In this one, A is under the Y and B is under the X. Where you put A tells you the direction of the ellipse. Okay, we're gonna get to this eventually, but I'm just trying to show you. If the bigger number is under Y, then the ellipse is gonna go in the Y direction. If you put the bigger number under the X, then the ellipse is drawn in the X direction, horizontal. So that's the thing that switches with an ellipse, that the bigger number can be under the X or the Y, and that controls the direction of the major axis. Yep.
What's B stand for again?
So we're going to go through what A, B, and C mean visually, because that is kind of important. This is the connection between A, B, and C. Kind of looks like something with Pythagorean theorem, but it's not really. But it's a formula that allows you to connect A, B, and C. And the idea is you're usually going to know two of them, and you're going to have to find the third one. So let me scroll down and see if I already have written what I'm going to do. Yeah. So I'm going to write down what A, B, and C are in a second. Sometimes it's helpful to get the intercepts. Not always, because you can have an ellipse that doesn't have any intercepts. So if it does have intercepts, those are easy points to find because you just plug in 0 for X or 0 for Y. All right, now let's go back up and look at A. Think about, all right, here's my ellipse. It says that the vertices are at negative A0 and A0. And here's the center. How would you describe what A is in relation to the center? What is A telling you?
The radius?
I'm thinking in terms of what does it tell you about the vertex? Yeah?
Are they equal distance from A? From the center? No.
Say it again?
So is B1 and B2 equal distance from the center?
Yes. And what is the distance from the center? John?
A squared.
Not A squared units. A units. Each vertex is A units from the center. Either A units right and left in this case, or it'll be A units up and down. So that's an important thing to know about A. It is the distance from the center to the vertex. So A is the distance from the center to the vertex. B, I'm going to have to tell you that one. That one's a little tricky, but let's see about C. This would be F1. This would be F2. What does C tell you? Kind of thinking along the same lines as what A tells you. Yeah?
The distance from the center to the focus?
Yes. C tells you the distance from the center to the focus. That's what C is. Still haven't described B. Well, if you know those two distances, you can calculate B. But what B really is the distance from the center to the minor axis. So if you're trying to sketch an ellipse, B tells you how far up, or how, yeah, in this case, it would be up and down the short line. So that's my ellipse. And I know that this point in black is B units away from the center. And this point in black is B units away from the center. What's the length of the ellipse the short way? What's the distance from here to here? What is it?
2c.
That would be the distance between the two foci.
2B.
2b, yep. So the width of an ellipse is always equal to 2b. How about the length of the ellipse? What's the length from here to here? 2a, yep. So the length of the ellipse is always 2a, and the width of the ellipse is always 2b. It could be a question they ask you. What's the length and what's the width of the ellipse? All right, so any questions on what A, B, and C are? I'm just going to write them down so I have them. A is the center to vertex, C is center to focus, and B is the distance to the minor axis. All right, that's all you really need to know. So, what we want to do first is, like we do with a parabola, figure out which version of the equation you use. But regardless of which version you use, it's always going to equal one number. 1. It always equals 1. You always put two fractions. And you always put a plus sign between the two. When you change it to a minus, it becomes a hyperbola. So ellipses and hyperbolas are very, very similar. All right, but we're going to put a plus sign for today. With an ellipse, x squared always goes in the top of the first fraction, and y squared always goes in the top of the second fraction. That cannot change. The only thing that can change is where you put the a and the b. Right, so this has to be x squared. This has to be y squared. If you're drawing an ellipse at the origin, every problem starts out just like that. Okay, now we have to decide where A and B go. So the way we're going to figure it out, we're going to graph all this information, and then we're going to see, does the major axis go horizontal or does it go vertical? You always put the bigger number, or you always put A under the letter you want the major axis to go. Let's graph these points. Doesn't say to sketch a nice picture, so I'm not going to spend a lot of time. I just want to get a quick idea. Here's my center. I have a focus at 3, 0. I usually call the ones on the left the ones, like focus 1, vertex 1, and I do the ones on the right, focus 2 and vertex 2. That's just how I do it. And we have a vertex at negative 4, 0. Well, where else do I have a vertex? They didn't tell me, but I have to. I have to have one at positive 4, 0. And I also have to have a focus where? Negative 3, 0. All right, so now, which way do we want the major axis to go? Horizontal or vertical? Yeah, you want the major axis to go right through all that information. So it's going to be horizontal, which means, if you remember, A is greater than B, A is going to go under X. That'll make the ellipse go in the X direction. If you put A under Y, it'll go in the vertical direction. So we want A, B. There's your equation. Now, we have to figure it out. A is the distance from the center to the vertex. What's that distance? 4. B, well, we can't really get that yet. A and C are usually the two you can get quickly. B, no, not so much. C is the distance from the center to the focus. 3. Now to get B, you use the formula C squared equals A squared minus B squared. So you could fill in the 4 for A, but you still don't know B. So let's get that. C squared, A squared minus B squared. Okay, what's C squared? 9. A squared? 16. So that means b squared is going to equal how much? 7. And you don't even need to solve for b. A lot of times you think, I got to get the variable by itself. You don't need to know b. Unless you're making a sketch, then you'd want to know b. But what you really want is b squared. So, what's going to be my equation? X squared over what? 16. Plus over what? 7. Equals. There's your equation.
Mr. Hager,
Yes.
we have two variables though. How do we graph that?
Let me write any more space. Let me write it down here. So I was just going to go over how we type that in. X squared over 16 plus y squared over 7 equals 1. Well, first of all, if I want to graph it by hand, that'll probably be faster. Let me do it that way first. Put this here. So I know I really need 4 points to draw an ellipse. 2 points that mark the length and 2 points that mark the width. So the points that mark the length are negative 4, 0, and 4, 0. And the points that mark the width are b. b is the distance from the center to the minor axis. So b is the square root of 7. So if we take the square root of 7, that's what, about 2.4, 2.6? Okay. So I need to go up 2.6, down 2.6, and there's your ellipse. It's going to look something, not the best at drawing ellipses. Kind of like. All right, so that's how you sketch it by hand. Now, if you want to sketch this on the calculator, what letter needs to be by itself here? Y. So what we have to do is move that whole thing to the other side. So we have 1 equals, actually let's do it like this. Y squared over 7 equals 1 minus x squared over 16. Instead of writing it as x squared over 16, I'm just going to write 1/16 x squared. I don't know if that's actually any better. And then how would we get rid of that? Divide by 7. Multiply by 7. So that's distributive property, 7 minus 7/16 x squared. And what would be your last step? Take the square root. And how many answers do you get? 2. So to graph an ellipse, this is what you'd have to type in. And as always with functions, we can't really graph an ellipse, so we have to cheat and kind of do the top and the bottom separate. Let's graph it and see what we get. Again, I think graphing by hand here was sufficient, but just to show you.
Can you graph it in polar now?
Yes, you can do in polar. We don't study conics in polar.
Okay.
I think conics in polar actually have easier equations, but it requires more time to spend on conics, and we just don't spend another couple days on it. All right, so square root of 7 minus 7/16 x squared. And I might have shown you this before, but if you want to type that whole thing in again as a negative, all you have to do is press negative, variables, y variables, and function. And what that's going to do is it's going to take y1 and just throw a negative in front of it. Is it quicker than retyping the whole thing? I don't know. Sometimes it is.
How do you do that? Negative what? How do you get the y1?
You just go to variables next to clear.
Okay.
And then you go to your y variables, because we're graphing something with y. And if we were in parametric or polar, we could choose those options, but we're doing something as a function. So I want to grab my y1 variable, and then it'll just put a negative in front of it. Let's do zoom. Let's do zoom square and see what it looks like. And I'm going to fix it so the tick marks are, oh, they already are 1 unit. Okay. Oh, I should have written it. So it's 4 units left, 4 units right, and it's 2.6 units up, 2.6 units down. And that's how you graph an ellipse on the calculator. It's exactly the same sketch. Any questions on what we did there? It's not really hard, it's just getting into the habit of remembering what the formula is and what A and B and C all mean. All right, let's look at this one. So discuss. Whether you're doing a problem that says discuss, or like we did in the last one, writing an equation, figure out your A, your B, and your C first. That'll help you to do everything you need to do. First thing you want to check, make sure it's in standard form. Yes. Standard form means it has a 1 by itself on the right, a plus sign between the fractions, an x squared, and a y squared. Okay. What's A in this case? 5. A is always the square root of the bigger number. B, we don't know. What's C? 3.
But I thought we knew B because B is under y squared.
Oh, I'm sorry. Yeah, you're right. We do know B. B is 3. And C, we don't know. Now, part of what you need to discuss when you describe an ellipse is the focus. What letter here has to do with the focus? C. C is the center to the focus. So you need C. So we've got A and B. Let's find C. What's the formula for C? Yep, A squared minus B squared. So that's going to be 25 minus 9, which means C is how much? 4. Okay. Now, we've got to figure out if the ellipse, which way the major axis goes. So that's the first thing I do, because that tells me, is everything above and below the center, or is everything left and right? Which way does the major axis go?
Horizontal.
And how do you know it's not vertical?
Because the larger number is under the x.
The bigger number is under the x, so it opens in the x direction. Yep. So major axis is horizontal. Where's my center?
Zero, zero.
Yep. You'll know when it's not 0, 0, because you're going to see something like this. Now you've shifted it 3 units horizontally, just like with a throw. Okay, so center is 0, 0. Let's see. Foci. How many units away from the center are the foci? 4. C is the distance from the center to the foci. So this tells you the foci. And they're horizontally 4 units away. So what would be 4 units away from the origin in a horizontal direction, left and right? What would be my coordinate?
Negative 4, 0, and 4, 0.
So negative 4, 0, positive 4, 0. If you can use the plus minus, that's fine. When you're at the origin, you can because it's symmetrical. All right? So remember the next thing we want to find, okay, we got the major axis, we get the center. Well, minor axis is obviously vertical, we could write that, but we want the vertices. Let's write that. How many units away from the center are the vertices?
5.
5. So remember, these tell you the vertices. and they're 5 units away in a horizontal direction. So what's the coordinate of the vertices? And I think that tells you pretty much everything you need. Questions on how we got that? Let's try another one. But now we're going to switch it. So instead of the bigger number being under x, we're going to do the case where the bigger number is under y. So that means everything is now going to be up and down. So all the x values are going to be 0 for the vertices and the foci. Major axis is going to go up and down. Still going to be equal to 1. Still going to have a plus sign between the fractions. X squared still goes in the top on the left. Y squared is on the top on the right. A is still bigger than B. And C squared still equals A squared minus B squared. The only thing that's changing is the position of the A and the B. Now, since A is bigger than B, and the bigger number is under the Y, the ellipse is going to open vertically. Or it doesn't open, it goes up and down. I don't even really think about all this when I graph it. I just remember what I wrote off to the side. A is center to vertex, C is center to focus. That's all you need to know. If you try memorizing all these coordinates, I think you're doing more work than you really need to. You do need to know this. C squared equals A squared minus B squared.
Do we get a note sheet for the test on Thursday?
We'll see on this one. I'm not sure, since it's only going to be on one, well, it's really going to be one whole section. We'll see. Okay. Want us to discuss this. What's wrong with this one?
It's not in the
Yeah, it's not set up correctly. So we're not even ready to find A, B, and C. What do I need to do first? Yeah, divide everything by 9. That will get it equal to 1, which is the format you need it in to find A, B, and C. Okay, so we're going to end up with x squared over, we still have to put something there. What's going to be in the bottom of x squared now? 1. Y squared, we'll leave it over 9. And 9 divided by 9 gives me 1. Okay. What is A? So remember, A is the square root of the bigger number. So what did we say it was? 3. What's B? 1. And the formula, C squared equals A squared minus B squared. So what is C? Square root of 8. And the square root of 8 when you reduce it? 2 square root of 2. So at this point, you've done really the hard stuff to figure out what you needed to. Now just describe the 4 things. Start with the major axis. What's the direction of the major axis?
vertical.
Why?
Because the larger number's under Y.
Larger numbers under Y. Yep. Okay, where is my center?
0, 0.
Yep, nothing fancy in the numerators, just an X, just a Y. The center is 0, 0. Foci. Now remember, everything is now above and below the center, not left and right. So what's going to be my coordinates for my foci?
0, 2, positive.
Positive and negative. So go up to root 2, go down to root 2. So there's your foci. right? And what about my vertices?
Would the foci be 3?
The foci?
Yeah.
C's.
Well, C is the number
never
for the
mind.
foci. Yeah. But A is for the vertices. So what are my two vertices?
0 plus or minus 3.
Yep. 0 plus or minus 3. Any question on that? All right, let's do, I don't want to sketch this on the calculator. Let's do just a quick sketch by hand because there will be some graphing ones. So if you're going to sketch it, all you really need is the 2 points that make up the length and the width. So vertices, 0, 3, 0, negative 3. You don't need to put the foci in the sketch, or the foci. And then the distance from the center to the minor axis is 1 unit. So 1 unit right, 1 unit left. And there are the 4 points that outline your ellipse. I like that.
How'd you get the 1?
1. B is the distance from the center to the minor axis. That's what B tells you. That's the only use for B. If you're graphing, that's when you need B. And to write the equation, but that's where it becomes important. B squared is what you need for the equation. B is what you need if you want to graph it. Okay, questions on the sketch? All right. Okay, you find the equation. Well, let's set up what we can first. What's it going to be equal to? 1. What's going to be on the left side? X squared and then what? Over something. Yep.
Plus y squared.
Divided by something. So we can set all that up. We just have to figure out these two numbers. All right. Figure out which way these points are lining up, vertical or horizontal. Yeah, I think you can tell they're going to be vertical. Your vertices are up 3, down 3. The foci are up 2, down 2. So everything's going to line up vertical, which means whatever you get, when you get A, what letter is it going to go under?
Y.
It's going to go under the Y. There's your equation. Okay, what's A?
3.
3, center to vertex. B is the one you can't directly find, but C you can. What's C? 2. And then what's my equation to find B?
C squared equals B squared minus B squared.
B squared minus B squared. So we get 4 equals 9 minus B squared. And what's B squared? 5. You don't need B. We're not sketching. Really, you need B squared. All right, so let's write our final answer. X squared over what? 5. Plus y squared over? 9. Yep. And there's the equation of your ellipse. Questions on them? So we're going to look at a circle really quick, but a circle is basically a special case of an ellipse. So let's go back here for a second. A gives you basically the distance from the center to the vertex, which is the long way. B is the distance from the center to the minor axis, which is the short way. Well, if these two distances are the same, A and B, then you have a circle, because you'd have something like this. Here would be your vertices. Let's say A was 2, and then let's say B was 2. Now you have a circle. And in this case, A is 2 and B is 2. But we really don't even need to call them A and B anymore because they're the same. 2 is really the what of this circle? It's the radius, exactly. So when A and B become the same, you can write it like this, but really A turns into the radius. And what they usually do when they write the equation of a circle, since both of these numbers are the same, you can multiply by that one number and move it to the other side. And that's the equation of a circle. X squared plus y squared. Usually we write r squared. So a circle is just an ellipse where the bottom two denominators are the same. And that's all I'm really going to say about circles. Because it's a circle, there's a few different terms. You don't have a major and a minor axis in a circle. You don't have foci. The foci are kind of merged into a single point, and we just call it the center. You now have a diameter, but you don't really have that in an ellipse. And you have a radius, where you don't have that in an ellipse either. Any questions on the equation for a circle? All right. So, an ellipse can have its center shifted. And when you shift it, we use exactly the same letters that we used when we did it with a parabola. H, comma, K. That will be the new location of the center. Still equal to 1. The x squared is still on the left. The y squared is still on the right. And if you want it to open horizontal, you put the bigger number under the x. But the difference now is x is replaced with x minus h. That's the only thing that's changing. Y is replaced with y minus k. Those are the only two things that change. A is still bigger than b, and c squared still equals a squared minus b squared. So h and k are the numbers after the minus sign. So if you ended up with a center that had a negative number, you could end up with like x minus minus something. So it could turn into a plus, okay, just like a parabola. And when I write the equation for the major axis being vertical, what's the only thing that's going to change between the two? What's going to change?
The a squared and the b squared.
Yep. The a squared and the b squared are going to switch places. You still put the minus h with the x. You still put the minus k with the y. You still square them. It's still equal to 1. Everything stays the same. This is on page 394 of the textbook that we're using, not your normal textbook. So make sure, again, for the homework tonight, look at the PDF. If you borrowed a book at the beginning of the year, don't use that book. All right. Questions on those two formulas? All right. Just try an example. Doesn't matter what you do. Are you finding the equation? Are you trying to come up with the equation? You need to know A, B, C, H, K. Find those 5 values first. Okay. What's H in this case? 2. What's K? You've already done the extra work that's involved in this problem. So you know the H and the K. Now, do it like you would normally do it. If you need a sketch, we could sketch the points. So your center is 2, -3. Your focus is 3, -3. And your vertex is 5, -3. I only sketched half of it. That's all mirror imaged in the third quadrant as well. Okay, A. What's A in this case?
3.
3. A is the distance between the center and the vertex. Those are 3 units apart. 2 to 5 is 3 units. B we don't know. C is the distance from the center to the focus. What's the distance between those 2 points? 1. And the equation for B, what is it? E squared minus B squared. Okay, so 1 equals 9 minus B squared. I think we had this exact pattern of numbers before. What is B squared? Well, yes, B would be 2 square roots of 2. B squared is the square root of 8. All right, so now you've got everything you need. You need the equation to plug into. Okay, what goes on the right? 1. What goes on the left? X, let's just get the letters first and then we'll fill in. Yep. And then what goes here? Y minus k squared. Now, which way do you want, or where do you want the bigger number? Under x, you want it to be horizontal. So this is a squared, this is b squared. Now it's just a matter of filling everything in. So it's going to be, John, what did you say? X minus what?
X minus 2 squared.
Yep. Over a squared, which is 9. Yep. Plus
Y plus 3k.
y minus minus 3, so y plus 3.
Squared over root 2. Square root 2, square root 2.
8. So b, I guess we don't really need b unless you're going to graph it, but b squared is what we need, which is 8. And that's equal to 1. And your equation. Questions on that? All right, last one. Discuss. Is that in standard form? Not even close. It's like somebody took something like this and they actually FOILed it out. And they wrote it as like x squared minus 4x plus 4. And then divided it by 9, and then they combined all the like terms. We need to make this look like the other one. What are we going to have to do here? And this is the last thing we did on a parabola problem as well. What is it? That's going to be part of it. Yep. Yep, and we're completing the square twice. Once for the x's, once for the y's. You're not completing the square with the constant, so you don't need to worry about that. So we should just take the constant and put it on the other side. But we should put the x's next to each other and put the y's next to each other. So let's just kind of set this up to get ready. So 4x squared minus 8x plus y squared plus 4y. And what will that equal? -4. Now, What did we always say when you want to complete the square? What number is supposed to be in front of the squared term? 1. Then the y's are fine. So I'm ready to complete the square on this one. I'm going to leave room to do it. Well, I won't leave room yet because I have one thing I have to write. Do we have a coefficient of 4 in front of the x's? I mean, do we have a coefficient of 1? No. So how do we get rid of this 4? We're going to factor it out. Now we're ready to complete the square. 2x. Thank you. Questions up to that step? Okay, now complete the square for the x's and complete the square for the y's. What am I going to add here to complete the square? 1. You take half of this number and you square it. Half of it is -1. Squared is 1. What am I going to add here to complete the square? Yep, half of this is 2. When you square it, you get 4. Now, we added some stuff on the left. We have to balance it by adding something on the right now, or this isn't true. This is not true the way it's written. We need something there. Be careful. What did I add in total on the left?
5.
It's not 5.
8.
8. We added 4 there and 4 there. Okay, so we added a 1, but it was in parentheses, which really means it's multiplied by 4. So we added 8 on the right. Now everything should factor very nicely, and then we can get it in the format we need. How does x squared minus 2x plus 1 factor? X minus 1. So it factors as x minus 1, x minus 1. And how does y squared plus 4y plus 2 factor? Y plus 2 squared. Now we're starting to see something that's looking very similar to an ellipse. What's the last thing I have to do to make this into an ellipse? Divide by what?
4.
Yeah, divide everything by 4. All right. I have directions on how to complete the square, but is everyone okay with the directions if I erase them?
Yes.
Okay, we are good. All right, so we're going to end up with x minus 1 squared over 1. Y plus 2 squared over 4 equals 1. All right. So, let's start with h and k. What's h? 1. What's k? -2. Right? Because it'd be y minus, and then it would be what's in the box after the minus sign. So there's your h. There's your k. What about a?
2.
2. B. Yep, we know that one. 1. And C. C squared equals a squared minus b squared. So what is C?
Square root of 3.
Square root of 3. All right. So now we have everything we need to discuss it. Let's write it down. Where is my center? HK. Yep. So that's where everything is going to be based off of as far as how far away it is. Which way does the major axis go? Yep, vertical. So everything is going to be above and below the center. So when I write my vertices, without doing any work at all, which number do I already know here is going to stay the same if everything is going to be above and below it? The x. So the vertices are 1 comma something. And what about the foci? What do I already know? It's going to be 1 something. What letter helps us define the vertices? A. So I need 2 units above the center and 2 units below the center. I'm not going to be able to use the plus or minus here because I wasn't at the origin. What's 2 units above the center?
1, 0.
1, 0. So I probably should have written this as 2 coordinates. And what's 2 units below the center? 1, -4. And the same for the foci, except we're not going to be able to write it as a nice answer. We're going to go √3 units above the center. Let's do it like that. And then go √3 units below the center. And that's it. That's really as bad as an ellipse problem can get, right there. Questions on that one? Yeah.
Why is 8
A is 2 because it's the square root of the bigger number.
2? Oh, okay.
So 2 and 1.
Oh, okay.
Any other questions? So that's the homework for the ellipses. Okay, so 13 to 17, and then the rest is odds. I think the 13 to 17 is matching, if I remember right. And then 21, 27 to 31 odd, 39, 41, 43 to 47 odd, and 55. All right, so we'll look at that tomorrow, and then we'll do hyperbolas, and that will finish up all the material for the week.